and it will lead into sigma notation. So this is your grade 12 work, and we're going to start with this introduction to sigma notation. So if we look at summing terms of a sequence, obviously summing means adding, okay? You're used to a sequence just having, for instance, if I've got the sequence 1, 4, 7, and 10. So if I say that we're going to sum the terms of a sequence, it means I'm going to add these terms together. So of the sequence 1, 4, 7, and 10, I'm going to say 1 plus 4 plus 7 plus 10 and getting that answer. Okay. So basically, if I wanted to say, with the summing of the terms, if I wanted to say I want to find out what the sum of the first 3 terms is, right? We would use the we use the symbol SN to denote the sum of the first n terms of a series. So remember, we use n to kind of say a general, all right? So like I was saying, if I want to know the sum of the first 3 terms, I would say S3. So that S3 just tells me I want to know the sum of the first 3 terms. So in the case of the example on the left, the S3, so the sum of the first 3 terms would be 1 plus 4 plus 7, right? And that would be, so that would give you 12, right? That answer. If I wanted S4, that's the sum of the first 4 terms. So 1 plus 7, 1 plus 4 plus 7 plus 10, okay? That gives me the answer 22. Okay. So for instance, if I wanted to say, let's do an example. Sorry, I'm just checking. Okay. My example, for instance, I want to know, determine the first 5 terms of the series. So there's an introduction to a new word. I'll explain it now. With general term so let's do 2k plus 4. Okay, so let's quickly just speak about that word series. Okay, so like I said, this you used to us calling a sequence, or in previous years it was number patterns. That's called a sequence, right? Now your series is when we start adding those terms. So sequence is without that's summing. Okay, it's just your normal sequence, your normal number pattern. A series starts as soon as you start adding those terms together. Okay, so if we say determine the first 5 terms of the series with general term 2k plus 4. Okay, so that means they basically want the sum of the first 5 terms. If they're talking about series, they want that summing. Okay, so if I have a look at that, that means that I would say, okay, term 1, I would put 1 in, and I would get 6. Term 2, I would put 2 in, and that would give me 8. Okay, term 3, I would put 3 in, and that would give me 10. Term 4, I do the same. I'd get 12. Term 5, now I get 14. And then I would add them all up together. 6 plus 8 plus 10 plus 12 plus 14. Okay, that is my series. And I would, sorry, I'm just getting my calculator. I put that into my calculator. So 6 plus 8 plus 10 plus 12 plus 14. That would give me 50. Okay, so that would be my answer. Now, it's all fine to do it, the first 5 terms first, 2 and so on and so forth. But what if you get to a place where they want the sum of the first 20 terms or the first 40 terms, right? Then it becomes a bit difficult if you keep doing it like this. So obviously in mathematics, they've developed an easier solution to this. And we now have a symbol. We're going to use the symbol called sigma. Okay, so sigma is actually the capital letter S in the Greek alphabet, but it's basically used to signify the summing of terms or summing of something. Okay, so adding something together, right? So for instance, okay, how it works is we would say sigma, we would put sigma, then at the top we would put n. Okay, now that n basically tells us how many, what term this sequence goes up to. Okay, then at the bottom we would say k is equal to 1, or we would say k is equal to 2. This k just determines where do we start. So in this case we would start at term 1. Okay, and then we would have t k. All right, so that is your sequence. Okay, so whatever, like for instance in this example my sequence was 2k plus 4, you would put that there. Okay, that might be confusing, but let's just wait until the example. So this n is last term number. Okay, what term number does it go up to? And this indicates to first term, first term number. And this over here is basically our general formula. General formula. Okay, feel free to obviously pause along the way if there's something that you don't understand. So let's do this an example, because hopefully it will be understood a little bit more. Okay, so for example, if we get the example or the question, calculate, okay, sigma 7k equals 1, 5k minus 3. Okay, for instance, if they give us this, so let's just read this how we understand it first in English. All right, so basically what this is asking me to do is finding the sum of the terms. Okay, here's my general formula, so I can see that it's a linear sequence. Okay, it wants the sum of the terms of this linear sequence starting at term 1 and ending at term 7. So basically they're asking, what is the sum of the first 7 terms, right? Okay, so basically what they want is, if we had to do this the long way, we would go, okay, T1, because it's starting at term 1, would be 5 times 1 minus 3, and that's going to give me 2. Term 2, 5 times 2 minus 3, that's going to give me 7. Term 3, 5 times 3 minus 3, that's going to give me 12. Oh, sorry, that was a bit strange. Oh dear. Okay, excuse me. Okay, that's going to give me 12. Term 4. That gives me 17. Term 5. 22. 6. 27. And 7. So last one. Okay, and then you would add all them together, because remember, sigma is telling us they want that series, they want the summing of all those terms. So we'd add those all together and we would get 119. All right. Okay, so let's see another one. All right, another example. I won't do the example, but I'll just explain what they're asking. So, for example, if they say sigma of 7 r is equal to 0. So I know in the previous one I used k, but now they can change it. They can use x, they can use n, right? They can use p, okay? As long as it's the same as in the general formula. All right, so let's see, what are they saying here? They're saying, okay, sigma tells me they want the summing, okay? They want the addition of all those terms, right? But they're going to start at term 0 and end, the last term is 7, okay? What's this general formula here? So you've got your arithmetic, you've got your quadratic, and then you've got your geometric. So we can see that this is geometric. Okay, it has the same formula format, all right? And now it wants the summing of those terms from term 0 to term 7. So if we look at this previous term, okay, it started at term 1 and went to term 7. Okay, so that was 7 numbers in total. Right? If we look at the second one, if I had to go from term 0 to term 7, that would mean I'm going to be adding 8 numbers in total, right? So now if we've got something like this, for instance, okay, this one over here that I've just written is also a linear term, okay, a linear sequence, right, an arithmetic sequence. Now it says I must start at term 2. They want to add from term 2 to term 8. Okay, they want to add those numbers together. So let's see if I did that. So I would start at term 2, which means I would say 2 times 2 equals 4. 2 times 3 equals 6. 2 times 4 equals 8. 2 times 5 equals 10. 2 times 6, 12. 2 times 7, 14. And 2 times 8. So remember they said up until 8, that last term. Okay, how many terms do I have here? I've got 1, 2, 3, 4, 5, 6, 7 terms. Okay, so now sometimes they're going to ask you the question, how many terms? Okay, or what are the number of terms to get this, answer kind of thing. So if I want to find out what is my number of terms, how many terms am I adding together, right? I would use this formula. So my number of terms is equal to, if I take the top minus the bottom and I add 1, okay? So for instance, if I've got my sigma notation and this is n, k is equal to m, and this is tk, then my formula for this would be n minus m plus 1. Okay, because if we look at this example here, at the top here, right, my top number was 8, my bottom number was 2. So I would say 8 minus 2 gives me 6. Then I would have to add 1, and that gives me 7 terms. So I know that I'm adding 7 terms together. Okay, what about this one to the side here, right? Okay, my top is 7, so I would go 7 minus 0 plus 1. So I would be adding 8 terms altogether. Okay, so let's do an example of writing a series in sigma notation, for instance. Okay, so let's do writing okay, writing a series in sigma notation. So say now I say write 2 plus 5 plus 8 plus, and it goes on up until 50 in sigma notation. Okay, so we know that this is a series. Okay, so they've added those the couple of terms together from a sequence, so they're adding them together, which makes it a series, right? Okay, and now they want it in sigma notation. So for me to do that, I need to think, okay, let's find the general term first. Okay, so let's find the general term first. I know that this makes a sequence like this. Okay, so I know TK is equal to A plus K minus 1 times D. You're used to N, which is fine. You can use TN if you want to. Okay, so my first term is 2, so that's my A. K minus 1, and my difference, so between 2 and 5, that is plus 3. Between 5 and 8, that's plus 3. Okay, so my difference is 3. I would distribute that in, so 3k minus 3, and that would give me 3k minus 1. So that's my general formula. So already in my sigma notation, I've got 3k minus 1 as my general formula. Okay, then I ask myself, all right, to find the number of terms, okay, I need to find how many, the number of terms that have been calculated. Okay, 50 is the last term in the sequence. Okay, so then we know, right, if I take the sequence and I find which term number gives me 50, let's find that. This would be 51 equals 3k, and that would give me 17. Okay, so term number 17 gives me 50. So I know that last number, okay, that last term is term 17. All right. Okay, and because we kind of started at 2, okay, let's see what gives us 2. So if I say, let me go back to that red. If I say 2 is equal to 3k minus 1, I get 3 equals 3k. So k is equal to 1. So we did start at the first term. So then I know, right, that we started at k equals to 1. So we've written that now in sigma notation. Okay. All right. So there's a few rules with sigma notation. Let's say sigma notation rules. Right? If I've got n and k equals 1, so sigma notation, and I've got a two sequences added together, okay, then I can say, okay, I take of the first sequence, and I can add the second. Okay, that's if I say, so say AN is equal to 2K plus 1, and BN is equal to 3K plus 2. If I added them together, it's basically taking the summing of one sequence of AN, and I'm adding the summing of the second sequence BN. So it can be written the same. It's the same as if I did 2K plus 1 plus 3K plus 2, and I add them together, it's going to give me the same answer if I work out the sigma notation for both. Another one to remember is if I've got sigma notation and I've got a constant times a constant times the sequence, then I can take that constant out and just work with my sequence, my series, I mean, right? So for instance, if I want to term 8 starting at k is equal to 1, and I say 6 times 3k plus 1, I can just take that 6 out and work out the summing and then multiply it by 6. Okay, you basically want to isolate those general terms. Okay, it's easier. All right, so I hope that this helps. In the next video, I will be explaining to find the answers easier to the sigma notation, but this is just an introduction into writing sigma notation.